Welcome to this week's Soroban design discussion. This is where we have public discussions about key decisions about the evolution and development of Soroban. As anyone who is here probably knows, Soroban is a new smart contracts platform that is designed to work well with Stellar. We are deep into its evolution. It's been on FutureNet since October. There have been, I believe, 7 preview releases of Soroban, and we are continuing to iterate, to focus, to hone in on important changes and decisions that need to be made, and to implement them as we move towards the completion of production-ready code. But today, we will be continuing to talk about some of the key decisions that still need to be made, and I feel like I have now stalled long enough to let people join. So, welcome. We sort of have a little bit of a loose agenda today, but I believe that there was something that we wanted to talk about, and I believe that Gerund is going to start by introducing the topic. Is that true, Gerund?
Yeah. Can everyone hear me all right?
Yes.
Yeah, we can hear you.
Cool. So I guess, for the last couple of weeks, we've been talking about the high-level archive interface. And this is kind of the interface where, with Soroban data types, we charge a fee for staying live on the ledger. And then if that entry does not pay the fee, then they are sent to this archive where you can then restore the entry for some fee. And so we've talked about it at the high level. And so today I'd like to talk a little bit about our implementation timeline for this project, and then go kind of a deep dive into some of the details in the first step in the implementation timeline. And so first off, I think in the last couple of weeks, we've been calling this the archival system. And we are officially pivoting naming-wise to state expiration, just to remove any confusion with like history archives or anything like that. And so I'll be calling it state expiration today, but it's still the same system we've been talking about. So first I'd like to talk about the timeline. So there's a lot of moving parts here, and there's a lot of complexity, especially with the structure of the storage itself, using potentially like a vertical tree or some new data types that aren't fleshed out super well yet. And so we are staging this in 2 parts. We have a part of the project that needs to be done when we launch Soroban PubNet, and then a second part that we can kind of finish later on after launch. And so at launch, there are 2 big components that we want to have ready and done. The first is we want to implement the rent system and temporary storage completely, which means that from day 1, Soroban entries will need to pay rent and also will have rent charged from them. And then secondly, we want to have the unique storage and recreatable storage interface finalized and exposed in the Soroban SDK. But we won't actually turn on state expiration yet. So what this means is on day 1, you can expect to have all of the tools you will need to deal with state expiration, even though entries will not yet expire and be sent to the deep storage, and they won't actually need to be restored. Kind of our thinking with this is that actually implementing the storage backend is a very significant problem that will take some time. But as long as the interface is set and finalized at launch, even though we haven't turned on state expiration yet, any smart contracts that are deployed on day 1 will have the proper interface and the proper tools to deal with state expiration when we do eventually turn it on later. And so kind of with that in mind, I'd like to talk about today some of the details between the rent implementation and the temporary storage implementation, as that's kind of the first step implementation-wise in getting state expiration into Soroban. And so first I'd like to talk a little bit about rent and some of the open questions we've had there and some of our findings. So we've discussed rent briefly before, where essentially every Soroban data entry will have a rent balance field attached to it. And this rent balance field contains some XLM that is tied to that specific data entry. And then periodically over time, the rent fee is deducted from this rent balance, where the rent fee is the fee for being on the net or being live on the bucket list for a given ledger. So the rent fee is variable based on the size of the bucket list, kind of in a similar way as to the bucket list write fee in the fee cap. The thinking here being that we want the rent fee to increase as the size of the bucket list increases. The reasoning for this is that as the bucket list gets larger, the fee for adding the bucket list also increases. And so we don't want this fee to grow exponentially or grow unboundedly. So by also having the archive or the rent fee increase at the same rate, what you can have is this equilibrium where as it gets more expensive to add to the bucket list and as the bucket list gets bigger, the fee increases. So it's more likely that more entries will be removed and deleted from the bucket list as they run out of rent and as they expire. And so we kind of have this equilibrium system set up with this variable fee rate. Now, in addition to the variable fee rate, I think one of the questions that we haven't really addressed yet is how we actually pay for the rent on these entries. And so initially, we wanted this process to be as seamless as possible. And so we wanted a way to automatically bump rent whenever you access items. The thinking being that the developer shouldn't have to worry about manually paying rent for entries that are used very often. And if an entry is often used, it should just automatically have a small rent bump so it's always live and it never gets sent to the archive. However, the issue with that is there didn't seem to be a good default behavior for paying rent, primarily because different types of contracts might have to pay rent differently. And so I think the big question here is who is responsible for paying rent? Is it the user who's invoking the contract that's responsible, or is it the contract maintainer itself who's responsible for paying rent? And kind of in our case studies, we've determined that there are two separate use cases that kind of illustrate this example well. So one example is you have a token contract such as USDC, where you have users that have an individual token balance that they kind of own. So even though Circle or some third party would be maintaining this contract, the token balances are tied to users. And so it seems to make the most sense that the user would have to pay to maintain that token balance. And so in the token contract example, you would want the invoker of the contract to have to pay rent fees. However, in the other example, you have something like an AMM. And say that we have an AMM that has a liquidity pool or an asset pair. Now, if you want to access this asset pair, this is kind of a public shared resource of the AMM itself. And so it doesn't make sense for the individual user who's accessing that access pair to have to pay for the rent, even if that entry would be used by many different users of the AMM. And so we kind of have these two separate cases where in the token contract, you have this kind of individual owned entry by one user, where in the AMM case, you have like the shared resource. And we wanted to see how we could fit the rent payment into that paradigm. And so there didn't seem to be a clear way to default bump rent because there's no good default behavior as to who pays, because it's very dependent on the contract and the data type that you're dealing with. And so instead of offering some mechanism to bump the rent by default, what we are doing instead is exposing two primitives that smart contract developers can use to define how rent is paid for their entries. And so what these two primitives are we're calling them rent bump and then rent bump from. And these are modeled after the token transfer contract. And so kind of in the native asset contract, you have two functions, which is transfer and transfer from, which is how you are able to transfer tokens. And so essentially, the rent bump and the rent bump from functions work in a similar way, insofar as you can define who the from address is from, so who is paying for the rent. And then also with rent bump from, you can also pay out of an allowance. So what this allows smart contracts to do is define who can pay. So for instance, in the AMM example, it might make sense that for every transaction in the AMM, a small fee is collected and put into a central shared pool. And then from this central shared pool, the AMM pays out rent to the shared entries. In this way, the cost of keeping those entries alive is spread out and amortized among the entire user base. And so you don't have one particular user that gets unlucky and has to pay to bump a rent entry if they just so happen to access it when it's low on rent. But instead you have this centralized pool that the contract can pay from. And then in the token example, instead of having a centralized pool, the user itself would have to bump rent. But we want to give flexibility. And so it might make sense for certain implementations to still want to have a user pay for rent. But instead of, for instance, for usability purposes, the contract would want to pay on the user's behalf. And so using this interface, because it's similar to the token interface, allowances can also be used for paying rent. So for instance, say that Circle, for whatever reason, wanted to maintain user accounts on the user's behalf, but didn't want to pay for it. What they could do is that they could, the users could give the contract an allowance, and then from that allowance, they could call rent bump from, and then bump the rent on the user's entries on the user's behalf. even without the user themselves signing or invoking that operation. And so with these two primitives, we think that we have a pretty good coverage as to the use cases, as to who pays and how you pay, and kind of allowing for these individually owned entry types and also these shared resources. And so I guess on the rent and rent payment front, are there any questions or anything that we want to talk about there?
Garen, it looks like there is a question from Moots in the chat, which is, does this mean contracts are responsible for exposing and defining logic to pay/bump rent for contract data entries?
Yeah, so the answer to that is yes. And so looking at, I think we were trying to, again, find a way to do this kind of under the hood without the developers explicitly saying it or explicitly defining it in the contract. But the issue is there is no good default behavior because of the different use cases between something like a token contract and an AMM. But looking at kind of the design paradigms that we're seeing in token contracts now, whenever it comes to state, a lot of contracts, including the example contracts that we have in the Soroban examples repo, have these helper functions for getting and setting values. And so I think what makes the most sense from a developer perspective is just adding an if statement to these getters and setters, which most contracts already have defined. And essentially what this would do is like, say you have like a get token balance function. What would probably make sense is that you have an if check there and say, if the rent balance of this entry is below, say, 100 lumens or whatever value you want, then bump it by 1,000. And so that's kind of how we're imagining this would work from a contract developer's perspective, is you'd have these getter and setter functions with this if statement check. And then this also allows the contract to define who pays and how you pay within this if statement. That's another important part of this, is that the current rent balance of the entry is exposed within Soroban. And so the smart contract itself can check the current rent balance and see if it wants to bump the rent or not bump the rent based on that active balance.
Oh, I have a question. I'm really concerned about the pool solutions just because it seems like too easy to abuse them by creating just a lot of junk entries that contract would bump unconditionally. Like, what do you think about this?
So I think this would have to be an implementation detail of the contract itself. But I think a smart or a wise development strategy for something like an AMM would be to have this fee pool, but to not pay rent for all entries equally. So for instance, one possible implementation would be that you have a fee pool and then you bump entries on access. And this is defined by the AMM contract itself. And so, for instance, if you have a junk entry that's never actually used in the wild, then its rent would not be bumped from the fee pool. Because at least how I'm imagining a solution would be is whenever a user accesses like an asset pair or something like that, you check the current balance or the current rent balance of the asset pair. And then based on that balance, decide to bump or not. And so in your example, if you have a spam entry that someone may try to game the system or drain the fee pool or something like that, first off, I would assume that the AMM would probably want to have some price to create an entry to deter spam like that. But also, if the spam entry is never accessed, then it would never enter that if check, and so its rent would not be eligible for bumping, if that makes sense. Cool. So I guess. Oh.
Garant, I have two questions. Okay, so the first one is about a state. So my understanding, and please correct me if I'm wrong, that at some point we want to kind of like get rid of some of the state and basically send it to archiver, right? And be able to delete it effectively from the ledger, and if needed, restore that later on. Am I correct so far?
Yes.
Okay, and I also assume that when we want to restore it, right, we will have some security guarantees, like cryptographic guarantees of some sort, like, as you mentioned, a Verkel tree or something of that sort.
Yeah,
right?
correct.
Okay, that's great. Now, I'm wondering what happens if, let's say hypothetically, I'm creating a application and so forth, and my transaction is such that I don't want my my ledger keys to eventually go to the archiver. I want them to disappear or dissipate into the nothing. And when sending the next transaction later on, I want, as part of that transaction, to send the content of the ledger key, where instead of going in during the execution time, the network itself would use that as the source of truth instead of going to the archiver, right? And from security perspective, that should be equal. However, it does give me, as a developer, the power to let my information not being stored on every node of the network forever. It basically moves the power to me, whereas the network is just storing the state. Does that make sense?
So if I understand your statement correctly, it's the network is storing the state, but not the key, and the user is responsible for maintaining their own keys. Is that what I'm understanding? I'm not quite sure.
Yes, exactly. So basically, I'm suggesting that the archiver is fine, and I realize that for the classic use case, you want to basically keep storing the state for everyone. But for some people that are very sensitive about their information, they might want to use the network to store the state with all the cryptographic proof, right? And everything, but without the data itself. And let the data be more ephemeral.
Okay, I understand. I think this is probably possible, and correct me if I'm wrong on this, but just in the current smart contract interface, right? I don't think we need to special case this into the archival system or the protocol level. So for instance, if you cared about this, what you could do is have a smart contract that takes a hash payload and stores a hash payload as one of its data members. And this hash payload could be the checksum or the cryptographic hash of data that the contract developer has off-chain somewhere. So I don't think this has to be a archiver protocol specific special use case. I think the current Soroban SDK already supports this. It would just be on the onus of the developer to make such a system.
Yeah. You're saying it would be already possible to implement it independently.
Yeah, because what you could do is just have a smart contract that has just define some key space, and then the values of those keys are a cryptographic checksum of data that's stored off chain. I don't think we need to special case that or should special case that because the tools exist already to build a contract that does exactly that.
I see. Interesting. Okay, that sounds interesting. Thank you.
Garen, regarding the fact that fees change based on the size of the bucket list, what is the expectation? How are users or developers expected to make decisions? Obviously, they want to pay rent for a specific amount of time, and they don't have access to this information, if I understand correctly.
Yeah, so this is one of the open questions, do we define rent in terms of XLM, or do we define rent in terms of ledger time? And so I think when we get to the temporary storage in a bit, we'll talk a little bit more about this. But I think from a market perspective and from a system performance perspective, it makes sense for the fee to be variable based on bucket list size, so we can have some sort of upper bound on bucket list size via this increasing fee rate. But from a user perspective, I do see how there's a significant advantage to having a definite kind of ledger, estimate, or as to how long something will live in terms of ledgers, instead of this ephemeral fee where something might last 5 months, might last 6 months, etc. And so I think what we decided in listening to some of the developer feedback on the Discord channel, it looked like that for temporary entries, it was important for temporary entries to have a definite, well-defined lifetime in terms of ledgers. That is, if you define a temporary entry that has a TTL of 128 ledgers, it should live exactly 128 ledgers, no less, no more. So I think that for temporary entries, especially for anything that might be a temporary allowance or a temporary auth or anything that has security implications, it is very important to have a definite ledger lifetime. And so for temporary entries, the plan is to offer a set amount of ledgers. And so how that will look is, in order to keep people from essentially abusing that power and getting free rent or cheaper rent, we would have to have some sort of upper bound as to the amount of time that a temporary entry can live. And so that could be like 3 months, 6 months, something like that. And then essentially, I think what we would have to do as far as the fee is concerned is that there's two options here. We could either just kind of take a best guess as to what the fees would be over the lifetime of that temporary entry and estimate and say, okay, like say the current rent fee, and this is just an arbitrary number I'm throwing out there, is 2 XLM per ledger. And so we're going to pretend that that stays constant and then charge this entry 2 XLM per ledger for its entire lifetime, and that's the fee of the temporary entry. That's one way. The other way is potentially is that we know that the upper and lower bound of the fees, because the bucket list can only grow at a certain rate as the upper bound. And so another possibility is to essentially charge the upper bound rent as if the bucket list was to grow as much as possible every single ledger. And then whenever the temporary entry gets deleted, refund the difference. But essentially for temporary entries, there will be some sort of fee model or some sort of something to ensure that it does have a very specific amount of ledgers it can live. Now, for the recreatable and unique storage types that could be archived, I think it matters. And again, I'm open to developer feedback on this. I think it matters less that they exist for a specific number of entries. So essentially, if you have recreatable storage and temporary storage, if you define 128 ledgers worth of rent, and then for some reason rent goes up and so it dies at ledger 125, you can still go and recover that. I think it would be annoying from a user perspective, and maybe like not the best UX, but I think it is a recoverable entry, and so there is no long-term permanent side effect for having a ledger that is archived slightly earlier or slightly later. Whereas for a temporary entry that's permanently deleted, if you access something that has 128 ledgers worth of rent and it's gone on ledger 126, it's permanently deleted and there's no recourse. And so I think because temporary storage and recreatable storage isn't being deleted, but just being sent to the archive, that the bounds don't matter as much. And especially since temporary storage and unique storage aren't intended to be used for these ephemeral kind of like author security purposes, there's not a security risk there. I think from a user perspective, what makes sense is that from the interface, expose paying rent in terms of ledgers, because I think that's the language that developers will understand. And so I think what we'll probably do is say, okay, I want to bump this by 1,000 ledgers or 10,000 ledgers or whatever. And what we would do is take the current bucket list price, do an estimation, and then I think what we could also do is maybe add an optional parameter to the rent bump that says, I want this much wiggle room. So say like I want like 10,000 ledgers worth of rent, and then put another 200 XLM in there just in case. And so I think this works pretty well. And I think that even though the rate is variable, I don't think it will. The growth is bounded, and also I don't expect it to grow or change quickly. And so I think if it's an entry that's being accessed often, and you're doing like this if check on every access, which is kind of the recommended design paradigm at this time, then as long as that entry is being often used, it doesn't really matter if, say, you're 5 or 6 ledgers behind where you thought you were going to be. You can still do that check, and if it's a frequently used entry, catch it in time and then bump the rent again. And so I think that's kind of what makes the most sense, is that for temporary entries, they have strict time bounds. For recreatable and unique entries, you pay rent in terms of time. They're not strict.
Garen, I was wondering if I could also mention something, or maybe even ask you about this.
Yeah, sure.
Well, it's just that you've been talking about these sort of arbitrary numbers of ledgers, and if my understanding is correct here, and there's no real future in which we're going to be deleting something at any point other than a bucket merge, right? I mean, we could factually pretend it had been deleted, but it's not actually going to be deleted until a ledger merge happens, right? Or sorry, a bucket merge happens, right?
Yeah, correct.
Okay, so those there are only 10 possible boundaries where that happens. So like it's not like you have arbitrary granularity here to sort of practically worry about. You basically you have like and most of those granularities are actually quite small. The bucket list is a little funny in this respect, in that a lot of the levels are actually quite short. They're 10 minutes, 42 minutes, 170 minutes, all the way up to level 6, right? So assuming you have any level of permanence to your problem, that you have a thing that you want to keep alive for any serious amount of time, you're probably only dealing with level 8, 9, or 10 granularity, right? Probably 9 or 10 granularity, which is, level 9 granularity is basically 7 days, and level 10 granularity is basically 30 days. So, like, as far as I can tell, the sort of the practical usability of this at a user interface perspective, all possible values that you could set rent to are practically probably going to collapse into some number of weeks or some number of months, and you'll just pick a week or month number, and that's sort of like, you can imagine there being some really complicated pricing mechanics in here, but like, practically speaking, I think level 10 merges happen about once a month, and so those are the only times in which you're likely to be talking about being expired. Does that sort of fit the user interface model that you have in mind, or am I just sort of missing the point?
Yeah, no, that's true. So we only would archive or delete entries during merge events, and then we're also conservative in how we charge rent. So this is also detailed in a document that will be shared later today. It's kind of like the first cap on this temporary storage and rent proposal. But the way that we charge rent is we charge rent during bucket merges. But because the fee is variable, we can't be up to date on charging rent, but we have to retroactively charge rent. Just because buckets are immutable, and then merge result of buckets are produced in advance. And so you can't charge rent until every ledger's rent is known. And so for that reason, essentially when charging rent, you lag behind one level. So for instance, if an entry is live in a current bucket at level 4, it has only been charged rent up to and including the ledgers that have passed to the bucket list level 3. It's a little complicated, but all to say, we are conservative when it comes to archiving and conservative when it comes to rent. And so I think from a user perspective, even if the price increases and you're off by a little bit, more likely than not, because of the conservative nature of our archiving scheme and because of the conservative nature of our rent charging scheme, it is significantly more likely that your entry will live longer than intended instead of shorter than intended. And so all this talking about, like, does it get archived like a couple ledgers early? This is kind of the most extreme case where you get really unlucky, or if you have like a small amount of rent that gets archived at like level 6 or 7, and then the bucket list grows the maximum amount possible for every ledger between creation and archival. And so this is very much kind of worst case circumstances. In the average case, your entry will most likely live longer than the rent that you supplied.
And I guess what I was getting at is that it's likely to last a month longer, right? Like if you make it over the line by a bit, you're probably not going to get touched for another month. If you're looking at sort of last level merges.
Yeah, it's a little bit.
I'm trying to understand, is grading suggesting that we change the interface to, rather than being like arbitrary rent deposits, you actually point at which next level do I want this to die on, basically?
No, I'm not suggesting a change of interface. I'm suggesting that the thought process that the user is going to be going through to try and calculate rent will realistically probably only have numbers that are multiples of 30 days worth of rent, because there's the next lowest multiple that has any meaning is only 7 days. I'm saying that you've kind of got a weird number system where you can target specific ledgers, but it doesn't. I don't think it's ever going to. I don't know. I need to think about this more, I guess. Sorry.
But wait, you're saying they like don't have to worry about being 5 minutes late on their rent. There'll be these big chunks of time. It's kind of like paying rent on an apartment. It's like every 30, you'll have 30 days of expiration, not like this super granular thing. So it'll be easier to deal with. Is that kind of what you're saying?
That's what I was asking, but I think Garen's point is that we are going to be doing it on every possible level. It's just we'll be one behind, and so.
So to kind of give a concrete example for this, say you have a level that contains like 30 days worth of rent, and then a user pays 31 days worth of rent. In order to be archived, you have to be at 0 when that merge event happens. And so because after 30 days, a mergeable event happens, but the entry still has 1 day left of rent, the entry is not archived and goes to the next level. And then say the next level is like 60 days. It will take 60 days for that bucket to merge. And so that entry will essentially live rent-free for 60 days while it waits for the next merge event. And then that merge event will check and say, oh, you're 0, you can be archived now. And so that's what I mean by we're lagging 1 level behind, and we have a conservative archiving and rent approach.
I think that's kind of what I was getting at was this idea that if it's not like if something survives a level 30 merge or a level 10 merge, which is once every 30 days there's a level 10 merge. Bottom level of the bucket list gets merged every 30 days. So if an entry survives one of those, we're not going to like suddenly notice that it's 1 day late the next day. We're only going to notice that it's overcharged 30 days, that it's past due, that it sort of ran out and doesn't have enough to survive another month 30 days later.
Yeah, that's correct.
And I think that's going to be almost every entry in the system is going to be in that circumstance, right? I think almost everyone who interacts with this system is going to pay at least 1 month worth of rent, and therefore they're always going to have like essentially 1 month of wiggle room in being wrong. Right. I think that's kind of what I was trying to get at.
Yeah, and I think from a design perspective, I think from a user perspective, that's nice to have some wiggle room. But also from a design perspective, I don't think our primary goal is to get rid of these long life entries that will never be used. And so if we are off by a month or 2 months, we don't really care. It's like we're trying to really limit ledger state size and get rid of these entries that last for years that don't do anything.
Exactly. The whole point here is just to have some upper bound, and it like having an entire month of wiggle room is completely fine from the operator's perspective. You just don't want to have we have entries in there that have been in there for years and years and years and years, and they're never going to be touched. And those are the ones we would like to oh come on, can we at least put these on a colder storage?
And I also I think Pyro asked an interesting question as to can a malicious user exploit this for free rent? And the answer is no. It's a little weird, but essentially, in order to get rid of programmatic exploits, where essentially you pay just enough rent to survive for the next level, and then always do that in a for loop over and over again, the way that we service archives is whenever an entry goes to 0, it is eligible for archive, but we archive in batches. And so essentially what we do is we use bucket hashes as a source of pseudo-randomness and then randomly pick batches to archive. And so to answer your question, while a user could get some free rent, kind of while they're in the 1 level below. So say because we lag 1 level behind, if a user pays 5 levels of rent, they'll live until level 6. But once their rent hits 0, the archive entries are deleted in a pseudo-random order. And so we're doing that to prevent programmatic exploits, where you have something like a smart contract that can just in a for loop continually bump the minimum amount of rent to live until you get to that bottom level. And so there is still some room for malicious exploitation, but because we service in a pseudo-random order, I think we're kind of limiting that attack surface.
maybe a related question actually to that, the batching thing that happens for actually charging rent. I mean, not charging rent, sorry, for archiving. So when it comes to those ephemeral entries, isn't the experience going to be similar where the, so that would be in conflict with having a, like an exact expiration for an entry to get deleted? Because
So
like I'm not going to actually do that. Like you'll have to, basically what we can do what we can enforce when you create an ephemeral entry, you can say, okay, this thing is going to leave exactly, some number of ledgers, right? And then that number has to kind of line up with probably the right merged number, right? In the bucket list. I mean, that's maybe, and that's a minimum. As far as that, is it a maximum? I don't think we can actually do a maximum, because if we do a maximum, that means that we are now creating those big waves of deletes that will all happen at exactly the same time, right? And that becomes kind of probably like a scalability problem, because kind of like the deletes, right, that are happening for the archive, or the archive events, right? It's kind of a similar thing where you don't want to do all the archiving all at once, because downstream systems, I mean, you have to tell them like that the thing got deleted, and you can't just do like millions of entries getting deleted all at once.
I actually disagree, and I think for two reasons. So I think first off, I don't think we should limit users to the bucket list time bounds, just because I feel like to the outside user it feels somewhat arbitrary. Like, why do I have to pick between 4,000 ledgers of rent and 16,000 ledgers of rent? That's a big difference. Why can't I go somewhere in between? So at least how I'm imagining temporary entries is that they have an internal field that's like a depth ledger. And then after that depth ledger, even though the entry might still exist in the bucket list, they are not accessible. And so even if you find the entry in a lookup, but the current ledger is past the depth ledger, then it's just as if that ledger doesn't exist. Now, as far as the deleting goes, I don't actually think there's an issue with deleting very large amounts of temporary entries and batches, mostly because I don't think you need to emit meta for temporary entry deletion. So, for instance, the reason why we have to do archiving in batches is because archive nodes or state expiration nodes, or whatever we want to call them now, need to ingest meta so they can store that information. But for temporary entries, because they have like this TTL value inside of them, I think they encapsulate all the information about their death. And so you don't need to emit any meta. So, for instance, a Horizon node, right, doesn't, and I could be wrong about this, so correct me if I'm wrong, but Horizon node on creation time knows what the TTL of a temporary entry is. And so the Horizon node or any downstream systems don't need a meta event emitted to say that the entry has died, because they know exactly when it's going to die. Similarly, whenever we delete a temporary entry after it's died, you don't need to write a deletion event to the top level bucket. What you can do is during the merge say, if the current ledger is past depth ledger, just drop the entry and not include it in the merge result bucket. And so I think because, assuming we have like a depth ledger field inside the temporary entry, we won't need to emit meta, and we won't need to write any delete events to the bucket list. So I believe we can do this with arbitrary size of temporary entries, and we won't have issues with like a very large batch being deleted at the same time, if that makes sense.
Well, kind of. I mean, that means that the downstream systems have to maintain and scan the entire ledger for those expired things, right? Like that's kind of overhead.
Yeah, so I guess that's the question, is if we need to emit meta or not, even if the depth ledger is included in the ledger entry.
Why cannot it be just like a logical thing? Like it's an entry, and then basically host knows how to treat it properly, right? Or whatever.
At the validator level, yes, we can do that. It's more like if you think of like Soroban or PC or Horizon, they would have to kind of manage with that stuff. Like either they do it on access, so like delete, they see the thing is deleted, or like past the expiration date, so they kind of delete lazily, or they do have to delete, like do a background, thing of sorts, right, to kind of discover the things that are actually expired.
I mean, I don't know how much overhead that would be to have like a delete on access if it's out of date, and then also just like keep a auxiliary table that's like a list of temporary, like pointers to temporary entries sorted by death ledger, and then just have a background garbage collection thread that runs every now and again, just to go down that list in order, and then delete the entries that have died. I don't know how much overhead that would be, but I feel like at least that was like, I was like kind of my thought was that would be like a DEMA kind of like logic bound operation and not require meta events. I feel like that should
I
be
think it depends-
reasonably
it
lightweight from an
depends,
implementation
like,
standpoint.
Yeah, it depends if we think that people are going to use a lot those temporary entries, and basically like like you create those things and then they expire, and then that basically you can do that because nobody's going to try to access them. I think for downstream systems, that implication is that the more likely scenario is that, you have to do some sort of garbage collection, because delete on access is not going to cover a lot of the cases where, you actually would delete stuff. So, this can be potentially quite a bit of churn stuff to do, but like maybe. I would like to hear what people on the platform side think about this, or like Orbitlens. I don't know if he's around.
He can't make it today, unfortunately.
Taking a step back for a second, I do think I'm very concerned about this this bifurcation of how rent is measured and deduced between the temporary storage and the recoverable storage. Rent is already a pretty novel concept, and I think we're treading unfamiliar territory. So having on top of that different mechanisms where temporary storage is measured in number of ledgers and then the recoverable ones are kind of like dynamic, I think that's weird. I understand why you want to do that, but I think from a user interface perspective, from developer perspective, it's going to be pretty weird. And not only that, but I do think that when a user pays for rent, they want to know, conceptually, they want to know exactly how many ledgers they're paying for. And this idea that things vary based on the size of the bucket list, which is an implementation detail from their perspective. I'm very concerned about that.
So one possible solution to this is to essentially have the rate be variable, but whenever you bump an entry's rent, you lock in the rent fee for that entry until the next bump. And so I was kind of imagining this as like a subscription model, where if you pay monthly, it might be $15 a month, but if you pay yearly, then it like amortizes to like $12 a month, so you get a small discount. And so I think this might work both to provide better guarantees around the expiration date for the recreatable and the unique storage types, and also still have kind of like a variable game theory aspect to it. Because my concern is if you have a fixed rate, then you can have people that like essentially like say, I'm going to like lock in this entry for 10 years, put up 10 years of rent, and then if it increases, like if the rent fee increases like 5 or 6x in that time, you just got a ton of free rent. But I think if you like reset the fee every time you rebump, it kind of makes sense from a fairness standpoint, I feel, because yes, you might be getting a better deal on rent, but you're locking up more funds. And so I still feel like the discount might be warranted if you're willing to lock up a year's worth of rent all at once to have like this fixed rate. And so I think that's one solution to provide a better user experience. And this would be very easy to implement as well. I just don't know if that could be gamed or be detrimental to the health of the network, having these like locked fees and having entries that are essentially like charged different fee rates based on the last time of their bump, if that makes sense. But what are some thoughts on that particular idea and that particular fee proposal?
Yeah, I think that the more you create like those type of discount systems, the more you create an incentive for people to be like meta aggregate, like like some sort of middleman contract that buys a bunch of space when it's cheap, and then you can use it. Like you can basically resell it to other people or something. Like I guess if it's for this would be read only. So maybe this, yeah, for stuff that's read only, maybe, I mean, this is maybe fine. Maybe this works. Like this wouldn't work if you allow people to basically, yeah, like allocate, with a bunch of zeros, right? Like stuff, and then later there's like a better deal because it's an update. But in the current model, we don't actually distinguish a create from an update. So I think it might work actually.
I don't think there is a good way to sell ledger space just because it's owned by the contract, and yeah, even as a contract storage, it's highly problematic and probably more expensive than for some rent savings. What I wanted to ask in this vein is how much do we actually expect rent cost to fluctuate? Because I'm kind of thinking about the model that we say, hey, the more entries are in the bucket list, the more expensive is the rent. But then, since rent goes up, we should evict entries from the bucket list, and rent suddenly becomes smaller for, yeah, I'm not sure if it is a good reason or not, because like we have just evicted a bunch of entries, right, to make it smaller. So basically the two concerns slash questions here are like, how much do we actually expect the cost to fluctuate at all, and whether we think it is fair, like in a way that some rent can like you may end up in this happy time period when a bunch of entries were evicted and suddenly rent is cheaper for you. So that costs someone being evicted.
So I think there's two things here. Well, first, I just like, again, back to napkin math, I don't expect it to grow very fast. But also, one other thing is that there is, because we are evicting in batches, the bucket list kind of shrinks at a fixed slow rate. And so, like, for instance, because of the batching system, there is no way for like, say, like 100,000 or like 1,000,000 entries to be batched in one ledger. And then all of a sudden, the bucket list price dramatically decreases, and you saved a ton of money if you would just like put your or create your entry or paid rent like one ledger later. That's not possible. So I think, generally speaking, the way that the fee structure is set up, you have a slow growth and a slow decline, and you shouldn't have ever have like any of these big jumps, either like a big jump up or a big jump down. It's more like over time you can see significant increase or decrease, but between individual ledgers or on a short time frame, you should only see gradual declines and gradual increases.
Well, with the caveat that, of those temporaries, like if we allow temporaries to go all the way to, let's say, level 9, you could actually see a big drop in ledger space, in ledger size, with basically when you adopt the bucket that has all those things actually deleted.
True.
And yeah, I'm just trying to think about it from the perspective of long lived entries, and I'm thinking about like how big is the downside of like doing the entry lifetime basically time based and not rent based, so that like as we have discussed in some thread, you are paying for a certain time period beforehand, right, when you're bumping the rent, and we would evict this entry based on this time period and not based on the variable fee rate. So given the fluctuations in the price and the this whole growth, I wonder how big is the impact of this approach would be compared to the doing completely dynamic rent, which who knows may in the end end up on average being the same as you have paid at the current rate beforehand for the whole period.
I think that if you go, and I think there's probably a number that makes sense, right? Well, if we say, okay, let's fix rent in granity, or like, I don't know, like let's say 6 months a year, I don't know, some number, right? What happens with that is that you end up with basically biasing rent so that the newer entries, like writes basically to the ledger, become a lot more expensive than existing things. Like you have like this, things get grandfathered a little bit, right, in the system. So that's where, like, if you pick that number, let's say you say like, okay, you get fixed rent for like 5 years, right? At the extreme, like as a way to kind of think about what happens, right? Like you basically are locking people that create entries now, right? When the ledger is small, you have like a really good deal, and then let's say in 4 years the ledger is much bigger and storage is much more expensive. At that point, those entries that prepaid are like have a very big advantage compared to entries that we try that try to get added to the ledger at that time. So that, I think that's what happens. If you make that number, like depending on how big that number is, you create potentially this big bias.
Right. Yeah. That's exactly the issue I understand we have. I'm just wondering, like, if you bound the ledger size, the rent cost has some bound as well, right? And let's say you reach this bound in a year, theoretically. That means that your 5 years of rent, the growth would be only during this first year, and then the remaining 4 years would be at about constant rate. I mean, basically, I'm kind of a bit concerned about the math going into this ledger bounding, because at some point you are going to reach the plateau where you would be evicting entries and the size is more or less constant, and then you don't expect much changes. So yeah, it's kind of weird. Like I'm not sure I understand the mechanisms that would cause the, like, let's say we are very close to the bound. What would be the rent increase mechanisms that pushes the entries out of the ledger, basically? Because like we are near the bound already. Like, do we have it or not? Sure, I understand.
Yeah, I'm not sure. Actually, you're asking if.
So basically, we want the rent fee to be a function of the ledger size, right?
Yeah.
But we also want the ledger size to be bounded at some upper bound, right?
Yeah, so essentially, like the idea being that the cost of writing a new entry and the fee rate as you approach the upper bound is asymptotic towards infinity is kind of the intention.
Yes, but it's in theory. But how does this work in practice? Like, what happens when we are near the upper bound? Like, can we not create any entries at all?
I mean, that's kind of,
Yeah,
it's not that you cannot create entries, it's just that they become very expensive. So in practice, you kind of stall network traffic.
Isn't that the same grandfathering issue you have? Basically,
What's that?
Instead of like saying that, entries were just created for cheaper, here we say that entries were just, like people were just able to get entries into the ledger, then it is prohibitively expensive to get new entries to the ledger until the older entries are evicted.
Yeah, I think there's definitely an issue if we have like I guess we'll call it rent control. I feel like there's definitely an issue if you have like long life rent controlled items, because essentially like kind of at the most extreme, if you had a lot of buy-in for like 5 or 10 year entries, then essentially your network would halt because there could be no other additional entries created, and so you'd have to wait until these rent controlled entries default on their rent, which would take 10 years at the most extreme. And so I think if we go this rent control approach, we'd have to make sure there's a very reasonable upper bound as to how much rent you could pay. And so like 10 years would definitely be too much. I mean, maybe 1 year, but I think we definitely have to upper bound it to kind of avoid this network being flooded with cheap entries and not allowing any other entries to join because it's prohibitively expensive.
Right. And then basically if we need some kind of bound anyway, like can we then consider the time-based option? Because like it seems like even the current approach, we have issues with very long-lived entries, right? If we flood entries with super long-lived entries, like we get people's basically fees burned at exponentially increasing rate, and then we get all of them evicted, and then we get them all recreated, like new entries recreated for very cheap. So it seems like it is problematic no matter what.
I want to say we are at time now. It's an interesting discussion, but I think we got to pause it. Garen, do you have what you need to move forward? Do you know what the next steps are? Is there any crucial thing that's blocking you that we need to address? Are you good?
Yeah, I think from my end, I'm pretty good. I have a timeline and then this cap proposal for rent and temporary entries I want to release, and then we can talk about more in the Google Doc. I think this time bound versus variable rate is still an open question that still needs to be solved. But I think there's still plenty to get done outside of that.
And is your intention when you complete the next iteration of or the next draft to share it here so that people can review it again? What's the story with that?
Yeah. So this will be a public document. Kind of the idea is like we have the timeline, and then we'll be linking caps off the timeline. And so this is just the initial cap off that timeline. And so both the timeline and the draft caps will be publicly available.
Awesome. Cool. Thank you so much. Well, good discussion. Super interesting. Thanks, everybody. We will likely have one of these next week, and stay tuned. Keep your eyes peeled for the drafts that Garen will share. Obviously, async feedback is also super helpful just to keep these discussions moving forward. See you all soon.